So we've covered terrestrial biomes. Now we're going to move into aquatic biomes. We covered all that stuff on land. Now we're going to go into the sea. And that's kind of important because, as you know, about 70% of the world is covered in water. So there's a lot of aquatic biomes out there. We just don't think about them as much. Whereas terrestrial biomes are going to be characterized by the amount of sunlight they get and their temperatures. Terrestrial biomes are going to be characterized more by their physical and their chemical natures. What's the chemistry like in the water? Light is an issue, but light is not so much a determining factor as it is on land, because with light, mainly what you're using is the amount of light to photosynthesize. You've got phytoplankton, as we learned about earlier in the course, hanging out at the top of the water column, taking in sunlight in order to produce sugar. They form a basal level of the ecosystem. But as you get deeper and deeper in water, more and more of that light is absorbed. Within the first 10 meters, so check this out, 10 meters, you lose 50% of your light energy. So that's 30 feet, you lose 50% of the light. 20 meters, you're going to lose, so 60 feet down, you're down to about 25% of the light intensity you had before. 75% is gone. 30 meters, about 100 feet, you got about 10% of the amount of light available to you that you would have on the surface. It's dark. The deeper you get, the darker it gets. But that's not all that's changing. You'll notice the varying wavelengths of light are starting to disappear as you go down. The long wavelengths, red, gets absorbed really, really fast, red and orange. If you go underwater and you're about 30 feet down, you're not going to see red or orange colors anymore. That coloration just isn't around. Yellow's gone by 30 feet, by about 30 feet. Then all you've got are blues and greens. What color are a lot of fish? Blues and greens, right? Especially the deeper you go, you're going to start seeing them, well, not the deeper. Once you get beyond where visible light penetrates, then they get all sorts of colors because it doesn't matter anymore. But those fish that swim down at this 100 or so meter level, you're going to see a lot of blues. Why are they going to be blue? Not trying to trick you. If all that's penetrating is blue, thus the water is blue, why would a fish be blue? It would help them blend into the environment, exactly. Think about this. A lot of fish, especially predators, are blue on top and white on bottom. Why might they be white on the bottom? Right, if there's white light coming, you see bright light at the top, by having a light colored belly, you're going to blend in more if something's looking up at you. If something's looking down at you and you're an ambush predator, you don't want to be seen. A great white shark is a perfect example of this. You've got an organism that exists throughout most of the water column. They're at the top and close to the bottom. That has a blue top, so that when seals are looking down, they can't see it. And a white bottom, so that when seals are looking up, they can't see it. It's kind of neat. That's actually, I was just watching a show recently. Basically, the cameramen were complaining that they couldn't see the great white until it was right on them. And if you watch the camera footage, they do just sort of come out of the blue about 10 feet away from you, and then that's that. Where that light penetrates is called the photonic zone. Photons, light. This is the area, roughly, it's about up to 100 feet down is where light penetrates. Beyond that, it starts to get really dark. The photonic zone is where you're going to have a lot of living organisms, a lot of organisms that are going to also rely on photosynthesis. But there's a lot more beyond the photonic zone. Once you get beyond where light, oh, yes?
So the Pacific Ocean and the Atlantic Ocean are often look different. Is that because of how deep the water level is?
So they would look different, not just because of how deep the water level is, because they're both really deep in places. Are you talking about like the way they look different with waves?
Like the color of the water.
Oftentimes that's very localized depending on what sediment's available. If you were to look at, say, the Chesapeake Bay, it's kind of brown. And the reason for that is there's a lot of silt churned up in it. If you look at the deep ocean, whether the Pacific or the Atlantic, it's going to be deep blue. And that's because there's not much sediment present high up. And it's so deep that light doesn't penetrate. Light doesn't get all the way down. It's going to absorb a lot. But if you were to, say, go to the Caribbean, it's going to be this very, very light blue color. Because at that point, light from the bottom is being reflected back up. It's not deep enough, which is, I think, is what you were saying before, too. Okay. Yep. The benthic zones are the area in which light doesn't penetrate. So anywhere from, it's about 100 meters down, or about 100 feet or so. You end up with an area in which there's no light, so you're not going to get lots of dependence on photosynthesis. I really do appreciate the benthic zones. Things get really weird down there. The mesopelagic, the bathypelagic, the abyssal pelagic, the hadial pelagic, they get deep, and there's some weird stuff. You get down there, and you start to see fish are entirely pink. Not because pink does anything for them, but color doesn't matter at that point anymore. They either have no eyes, because who needs them, or their eyes are very, very large. There's one type of fish that has its entire top of its head is translucent, so that its eyes can see up through its head. Kind of weird. As you proceed deeper, you're going to find that water temperatures drop. The deeper you get, you got two big issues: pressure and temperature. At the surface, water temperature varies. It could be really, really warm at the equator. It could be really cold at the poles. You've probably seen ice flows and things up at the poles. The equator doesn't necessarily have those. You get a wide variation at the surface. But the deeper you go, you're going to find that all of the ocean temperatures reach about the same temperature. It's roughly 4 degrees Celsius. Why is 4 degrees Celsius so important? Why is everything all around the world 4 degrees Celsius at the bottom? This goes back to Bio 101, your properties of water. Any idea? Why? Okay, how about this? Why does ice float? No, not because it's full of air.
Buoyancy?
Yeah, it's got a higher buoyancy, but why? The answer to that is, and you all knew this last semester, trust me on this. As water cools down, just like anything else, it condenses. But at 4 degrees Celsius, it is the densest it will ever be. Beyond 4 degrees, all of those hydrogen bonds in the water begin to assert themselves and create a crystal lattice that pushes those molecules apart.
How were we supposed to guess that?
Because you learned it last semester. It was a major property of water. You did a whole experiment where there was, how about this? Do you guys remember you did this experiment? There was a big thing of water, and you made like red water, and you put a blue ice cube in it.
I remember that.
And then the blue on the ice cube sank to the bottom because that blue was cold water. So the cold sank, but the ice cube, which was even colder, hung out on top. Because ice is less dense than 4 degrees Celsius water. You right? But because of that, 4 degrees Celsius water always sinks to the bottom. All across the world, 4 degrees Celsius at the bottom. If you were to ever go to a deep lake, and let's say you're hypothetically on a boat, and you've been hypothetically drinking during the day, and somebody says, hey, do you want another drink? And you said, sure, throw it to me while you're in the water. And they throw it to you, and you miss it because your reflexes aren't as good as they were a few hours earlier. And that bottle misses you and goes straight to the bottom of the lake. It will sit down there at 4 degrees Celsius, better than in a refrigerator until somebody finds it, at which point they can open it and it'll be awesome. Nice and cold. Make sense? Bottom, 4 degrees, all over the earth. So you have a very, very cold layer and a very warm layer at the top. Okay, you know a better way I can explain this. Has anybody ever been to a lake and you've jumped off a boat? In the middle of the lake. Okay. What happened to you when you've gone from the boat into the water? The first layer of the water was probably pretty warm. As you jumped deeper, it got cold really, really fast. Am I right? That's what's called the thermocline. There's a warm layer at the top that's lighter and less dense, and it hangs out up there. And you get beyond that, and you hit freaking cold. The oceans are uniformly cold at the bottom, and depending on where you are on the planet, maybe warmer at the top. Because of that, the organisms that live at the bottom have pretty uniform distribution all over the Earth. If you find something living at the bottom of the sea at one part of the planet, you're going to probably find it at just about any other part, from the equator all the way to the poles. There is very, very, very little variation in the deep sea biomes. They stay cold year-round. Higher levels, it can fluctuate with seasons. And that's where you see a lot of fish migrations, in the higher levels of the thermocline. Lower down, stick around where you are because nothing's changing. So there we go. The aquatic biomes are going to be determined they've got a lot of issues dealing with depth. So how deep down are you? Not so much temperature. Temperature doesn't play as much of a role here as it would in on land, but also chemistry is going to play a major role. How salty is it at any given point? Some fish tolerate salt, some don't. You guys know my irrational fears. Another irrational fear, because I have lots, is bull sharks. Bull sharks are one of the few species of shark that can live in a saline environment and a freshwater environment. They've been known to swim up rivers. So, you know, if you're swimming in a river, not necessarily safe. I mean, you wouldn't want to swim in the James River anyway, because obvious reasons. But there have been sharks caught in the James, right? Pretty cool. There's been a bull shark caught up the Mississippi, up in like Illinois somewhere. Pretty fun.